All right, so we square both sides. The squared and the square root cancel each other out. We get k squared equals 20 minus k. That's a quadratic equation. And this time, unlike the first one we did, the k squared is not going to cancel out. If I want to factor, I want that k squared to stay positive. So I might, even though I'm going to have to move two things instead of one, I might move these two things on the right to the left. We can do that by adding k to both sides, and at the same time, subtracting 20 from both sides. So we get k squared plus k minus 20 equals 0. We could have moved the k squared to the left, but it would have ended up being negative k squared. And then if we wanted to factor that, we would have to have made it positive k squared probably, because it is more difficult to factor when k squared is negative. If we're going to factor this, what can we multiply to get negative 20? That adds to give us positive 1.
5 and negative 4.
A lot of us can do that just thinking about it. Like, hey, I know it's going to be 5 and negative 4. Some of us maybe have a little more difficult time trying to figure out those numbers. So what can we do to try to figure out these numbers? We can take 20, because I know it has to multiply to give me 20, and we can divide. In order, 20 divided by 1 is 20. 1 plus 20 is 21. 20 minus 1 is 19. That doesn't add up or subtract to give me positive 1, so I know that doesn't work. And we just keep dividing in order. 2 plus 10 is 12. 10 minus 2 is 8. I'll work out the signs in a minute. But that doesn't work either, so we divide by 3. We divide by 3, we get a decimal. We're not going to use decimals, so that doesn't work either. We divide by 4, we get 5. 4 plus 5 is 9. 5 minus 4 is 1. So that's probably the combination of numbers that we're going to use. And even though we might not be able to think what those numbers were, we can figure them out. So it is going to be 5 and 4, and the 4 is going to be negative because we want positive 1. We want it to add up to positive 1. So we get k plus 5 times k minus 4 equals 0. That's not the final answer, though, because we still haven't solved for k. We would technically set both of those equal to 0 and then move that number to the right. So k plus 5, we would have to subtract 5 from both sides. I'm not going to show that here, but that would be negative 5. And the k minus 4, we would have to add 4 to both sides. So we get k equals 4. So our two potential solutions are negative 5 and 4. It is possible that they both work. It is possible that only one of them works. It is also possible that neither of those two numbers work. How do we know? We don't until we plug them in and try. So we're going to plug negative 5 in. We're going to plug negative 5 in before we square it. So before we square it, does negative 5 equal the square roots of 20 minus negative 5? You type that right side in the calculator. It's going to say positive 5. Does negative 5 equal positive 5? No. So k equals negative 5 is not a solution to our original equation. We would call this yesterday, we call this an extraneous solution. What about 4? If we plug 4 in, what do we get? We get 4 equals the square roots. Does 4 equal the square roots of 20 minus 4?
Yes.
Yes. So x equals 4 or k equals 4 is the only solution to this equation. K equals 4 is the only solution. On a multiple choice test, it's not going to differentiate between extraneous solutions and non-extraneous solutions. So option A might say negative 5 comma 4. That's wrong. You did all the work right. Option A is not correct. Option B, 4, would be the correct answer. So make sure you check your answers on your test. I promise you that's going to happen on at least one question. You're going to get one of those answers is going to be extraneous, and the answer choice is going to be both answers. And some of you are going to miss it because you're just going to pick both answers. All right, cool. Next example, very similar to the one we just did. But notice the negative x is not under the radical, and the radical is not by itself. So the first thing we want to do before we start trying to square both sides, we want to get this square root over here on the left by itself, and we can do that by adding x to both sides. So we get the square root of 5 minus x equals, typically we put the x in front, but it doesn't really matter. So the square root of 5 minus x equals x plus 1. How can we get rid of the square roots? We can square both sides, absolutely. The left side, the squared and the square root are going to cancel out, so we just get 5 minus x. The right side is x plus 1 squared. I'm just going to write that over again, because we need to spend a minute talking about x plus 1 squared. X plus 1 squared. Some of you might be thinking right now that x plus 1 squared is x squared plus 1. And I'm here to tell you that it is not x squared plus 1. So what is x plus 1 squared? X plus 1 squared is really x plus 1 times x plus 1. And however you want to multiply that out, however you learn to multiply that out, I don't care. You can do the box method, FOIL, the double distributive property, whatever you want to call it. But we have to multiply this together, maybe using a box. Most of you probably learned the box, maybe. X times x is x squared. X times 1 is 1x. 1 times x is 1x. And 1 times 1 is also 1. So do you get x squared plus 1? Yes, you do get x squared plus 1. But you also have 2 other boxes there that you would have left off. And you would not have added that 1x and that 1x to your answer on the right side. So we need to make sure when we see something like x plus 1 squared, we multiply it out. Because if we don't multiply it out and we just try to say, oh, it's just x squared plus 1, you're going to be missing the 2x in the middle. The 2x came from adding the 1x and the 1x together to get 2x. But if you just say, oh, that's just x squared plus 1, the 2x is not going to be there, and you're never going to get the right answer without the 2x. So to get 0 on the right, I would add x to both sides and subtract 5 from both sides. We get 0 on the left. We get x squared. 2x plus x is 3x. And 1 minus 5 is negative 4. Hopefully we can solve x squared plus 3x minus 4. I'm not giving you like super complicated quadratic equations to solve. They're all fairly simple, pretty small numbers. We don't have to find numbers that multiply to give me like 216 that add to give me 84. We're not doing that. So what can we multiply to get negative 4 that adds to give us positive 3? Negative 1 and positive 4. So our 2 possible solutions are going to be x equals positive 1 and x equals negative 4. We have to switch those signs because we would add 1 to both sides. We would subtract 4 from both sides. Now, do they both work? They might. They might both work. We need to plug them in and check. Plug in 1, it's going to work. Plug in negative 4, it is not going to work. Now that I know of them. And I didn't even use this card, I used card 6. But no, there was none that they could not sign it to. Correct. Correct. Yes. So, but I think card 6 did that. So for some reason, Mr. Chapman does that one, or he came out now. Or you guys don't want to do it. Oh, yeah. All right, so plug in 1. 5 minus 1 is 4. The square root of 4 is 2. And 2 minus 1 is 1. So x equals 1 checks out. Plug in negative 4. 5 minus, you got to be really careful when you plug in negative 4. Because you start subtracting negatives. When you type that in your calculator, you're going to have minus a negative. And if you leave the minus negative off, it's not going to work out. So we get 5 minus negative 4 minus negative 4. That's what you should type in your calculator. The left side, 5 minus negative 4 is 9. The square root of 9 is 3, and minus a negative 4 is plus 4, and 3 plus 4 is 7. Does 7 equal 1?
No.
No, so x equals negative 4 would be an extraneous solution. X equals negative 4 would be extraneous.
Is it possible for both of them to work?
It is possible for both of them to work, and on your classwork today, there will be some problems that they both work. There will be some problems that both of them do not work.
So would that be?
It just depends, that would be no solution, that's correct. It just depends on the problem. The ones we did, only one of them worked, but it is possible they both work. It is possible they both do not work. So teaching you how to do math is cool and all, but if it's not applicable, there's no point in really learning it. So I try to show you how we can use this before you even ask. So here we go. The formula, S equals the square root of 30, F times D. If you're in physics, you might have seen this the other day when the state patrol guy was here. It can be used to estimate the speed in miles per hour that a car is traveling when it goes into a skid. It slams on the brakes, the wheels lock up, and that car is just sliding across the top of the pavement or the asphalt. F is the coefficient of friction. D is the length of the skid mark. F, the coefficient of friction, is something that the state patrols can actually go out to the crash scene and they can actually calculate that number. If you were in physics, you saw it, but they had a tire. They would pull that tire across the ground. They would calculate how much force it would take to pull that tire. And if it's slippery outside because it's raining or it's black ice conditions, that tire is going to be easier to pull across the top of that roadway. If it's hot, if it is dry, it's going to be harder to pull that same tire across that roadway. So this friction coefficient, 0.7, probably a pretty dry, warm day. Pretty dry, warm day. Numbers close to like 0.4, probably raining outside or has been raining. The roads are wet. Numbers close to like 0.2, probably black ice conditions. That car is just sliding right across the top of the roadway. Not a whole lot of friction there. What else might affect it? The slope might affect it. If that car is going downhill when it locks down the brakes, it's going to take longer for that car to stop because it's going downhill. What if that car is going uphill? Probably stop in a much quicker amount of time, right? Or the skid mark would be much smaller because it's going uphill and it's not going to slide as far because the hill is also helping stop it. So Cody skids to a stop on a street with a speed limit of 35 miles per hour. His skid marks measure 52 feet. That's something that you can actually go out like, hey, here's the skid mark on the road. Let's measure how long that is. So we measured Cody's. Cody's was 52 feet. The coefficient of friction, which we obviously can't calculate in here, but somebody could go out and actually figure out what that number is 0.7. Cody says he wasn't speeding. Cody says I was only doing like 30 miles per hour. And Cody wants to prove that he was only doing about 30 miles per hour when he slammed on the brakes. So, part A, how long would the skid marks be if he had been driving at a speed of 35 miles per hour? So he's going exactly the speed limit. This is going to be our S value. That's going to be this number right here. So 35 is equal to the square roots of 30 times this coefficient of friction that the state patrols can go out and actually measure and calculate using some tools and instruments that they have. And D, we don't know what D is this time. We're saying if he was doing 35 miles per hour, how long would his skid marks be? So we don't know what D is in this case. That's actually a really simple equation to solve. We can square both sides to get rid of the square roots. 35 squared is 1,225. You can go ahead and multiply the 30 and the 0.7 together if you would like. 30 times 0.7 is 21. If you got a decimal, you do not want to round that decimal. And I think I went and during my planning period, I went down and listened to the state patrol for a little while. And I bet like the 30 minutes I was there, I bet he said 10 different times, do not round, do not round, do not round, do not round. What if you round 38 to 40? it's gonna be inaccurate at that point, so do not round. So 21, we actually don't have to round 21 because it's just 21. But if we were to get a decimal there, you do not want to round anything until the very, very, very last step. So 21 divided by 21, so 1225 divided by 21. His braking distance or his skid mark, if you type that in the calculator, was 58.3 feet. If he was doing 35 miles per hour. If he was doing, you got 53.8? You typed something in wrong. Do 1225 divided by 21. 1225 divided by 21. You may have did 1225 divided by 30 times 0.7. And if you do it that way, you need to use the fraction button. Because you will get the wrong answer if you do 1225 divided by 30 times 0.7. Because what your calculator is actually doing is dividing by 30 and then multiplying all of that times 0.7. So that would be my guess is what you did. I don't know for sure though. So part B. Can Cody prove that he was speeding or not? Was he speeding? He was not speeding. Cody was not speeding. And how do we know Cody was not speeding?
From that?
Not that they don't match. He didn't go 58 feet. If he was doing 35 miles per hour,
Oh, yeah.
he would have went 58.3 feet. How far did he actually skid? He actually skid 52 feet, which is less than 58.3 feet. So since his skid was only 52 feet, Cody had to be doing less than 35. If he was doing more than 35 miles per hour, his skid length would have been longer than 58.3. But he was doing less than 35. Part C, can we actually calculate his actual speed? Yes, we know his skid length. So S equals, and if you did the physics thing the other day, you really just did part C. You didn't do part A, which is okay. We get the 30 times 0.7, and we know his actual skid length is 52. We can type that in the calculator exactly like it looks to determine how fast he was traveling when he locked the brakes down. You should get like 33.04, which is okay at this point to round to 33, right? How fast was he going? How many people are you going to hear say 33.04 miles per hour? Probably not many, right? So it's perfectly okay if we go ahead and round that to 33 at this point.